Hi, how's it going? Okay, so I'm going to be working through a problem from the final exam question, spring 2019, question number 7. This is a volume of revolution question, and basically what we're being asked to do is look at, we've got these couple of different equations. So the first one is y equals x squared minus 6x plus 10. Okay, so it's bounded by this one, and it's bounded by the graph of y equals 10 minus 2x. And they want us to, part A and part B, we're going about the x-axis, and then part B is going about the line y, x equals minus 3. So the first thing I do when I get these problems is I like to come up with a graph just to get a visual for what this thing looks like. And because I know in part A it says the x-axis, but part B says the line x equals minus 3, so I'm just going to try to include my second quadrant in my graph as well. So I used also my calculator on this too, just to help me take a look at the graph. So 10, and then I've got 1, 2, 3, 4, 5. And then here's our x-axis. So the first thing is we're going around the x-axis. 1, 2, 3. Here's the line. X equals minus 3. So be careful when doing these problems, because like part B says, we're going to go about the line x equals minus 3. X equals minus 3 is a vertical axis. It's parallel to the y-axis, right? So we're going to be doing 2 different types of methods here when we do this stuff. So let's go ahead and plot first. 1, 2, 3, 4, 5. Here's 5. I'm going to plot my linear equation. So 10 minus 2x is going to look like, let's see if it looks, oh, I didn't put it very well. Let me try it again. Get this right. It's going to go through here. This is 5, and it's going to go through here. That's 10. Okay, so this is y equals 10 minus 2x, and then I've got my parabola that looks like it's about, and it kind of cuts down. It goes intersected there. You see why I'm just doing that. Okay, so this is the shaded region right here that we're going to be using to revolve around the x-axis, and then again around this line, x equals minus 3. So they're not telling us like the bounds of integration on here, so we have to be able to set these 2 functions equal to each other and see where they intersect, right? You can also do this by graph, but you're going to want to be able to show, you know, essentially what are the bounds of integration on here. So I'm going to set these 2 equal to each other for the points. Points of intersection. So I'm going to say my first graph, this is x squared minus 6x plus 10 is going to equal 10 minus 2x. Okay, so the 10s cancel, right? And I'm going to add 2x, add 2x, x squared, sorry, not plus, x squared minus 4x equals 0, which is going to give me x minus 4 equals 0. So the points of intersection are going to be x equals 0 and x equals positive 4, which you can also see on the graph. So x equals 0 and then x equals 4. Okay, so this right here is going to give us our bound of integration. So when we go to integrate things, we're going to go from 0 to 4 because that bounds this region right here. It tells us what the area that we're trying to do. All right, so now that we just have a graphic visual for what we're taking a look at, this way so we can see that these things parallel with each other. All right, so part A, part A says we're going to go around the x-axis. Okay, so when I go around the x-axis here, right, I'm basically kind of looking at, I've got another shaded region. It kind of goes like this, like this. So I've got, it kind of looks like this. So I'm getting this little, you know, bulbous shape, and it's going to scoop around, and I'm going to have this empty spot here, but it's going to carve out this space here as I go around. This is our disc or washer method. Which is a good method for going around a horizontal axis. Okay, so this method relies upon taking a look at, we're going to integrate our pi r squared. Okay, so this gives us, this is a circle, right? So pi r squared gives us the area of that circle. Okay, so now, but what I need to think about is I've got 2 functions here that are forming that. It's not going to be just a solid line. Like if I was just doing this linear equation, right, and I'm going around the x-axis, I would have a solid shape that would be going around. But I've got this empty space on the inside as the shape is being rotated around. start to think about my radii. So I have a radius for the outer, right, which would be this top function here. So this top function is going to go on the outer side. It's going to form the outer part of our curve. Okay, so the radius of our outer is formed by our upper function, which is 10 minus 2x. And our radius for our inner, our inner radius, right, that's the distance between here and here, that's our lower function, okay? So our lower function is defined by x squared minus 6x plus 10, okay? So when I do these here, right, I want to think about, I'm going to go pi r outer squared minus pi r inner squared, okay? And I'm going to integrate both of these here, okay? And this will be a dx, right? So now we tend to factor out the pi, but just make sure that you recognize that the pi gets, when that gets factored out, we're talking about pi, and I'm going to go from 0 to 4, okay? And then I've got my r outer squared. So this is my radius outer, 10 minus 2x quantity squared, minus, right, I factored out the pi. My inner squared is x squared minus 6x plus 10 quantity squared. I'm going to close the bracket and then say dx. Okay. And then I'm basically done. I don't have to do anything more. It just said to set up, but don't calculate. Because we're just looking for essentially how are we going to set up that integral, which means that you want to be really careful about all the detailed points, right? I've got the pi r squared. I've got the outer minus my inner, okay? So this is our outer function or inner function. It's r squared minus r squared. It's not r minus r quantity squared. It's r squared minus r squared because we're doing this right here, okay? Okay, I'm taking this out here. And think about it as I've got these two circles and I'm subtracting out that area, okay? So that gives us going around the x-axis, okay? Let's take a look. What part B says we're going to go about the line x equals minus 3. Okay, so x equals minus 3 is a vertical axis. Let's just take a look right here. So x equals minus 3 is right here, right? Which means, you know, basically I've got this shape, you know, it looks like this, a little bit mirrored. I've got this, going to curve around this way. Okay, as I go around, I'm going to create this shape that goes around this axis right here, my vertical axis. When we do things that are a vertical axis, we tend to think about our shell method. Okay, and the shell method, remember, is based on, we're going from A to B, okay, and we've got 2 pi r, because we're creating a circumference, 2 pi r, that's our circumference of that circle as we go around. Okay, 2 pi r, that's our first dimension, times, I'll call it the height as a function of x, and then the thickness of each little circle, dx, okay? So the things that we need to calculate are our radius and then our height function, okay? So in this particular case, our radius, how we're going to think about that radius is, remember in the shell method, typically, if I'm just going around the y-axis, say for example, like I'm not going to go around this x equals mentioned, I'm just going to go around the y-axis. My radius is just simply x. How far out within this range have we actually gone, right? I'm going to integrate from 0 to 4 still because that defines this solid region here. But my radius, right, as I go around this here is just x, right? So now instead, I've got a differential that's happening, okay? So my radius is going to be x minus a minus 3 because I'm going from x, I have to subtract out this difference here, but I've got a minus 3. This ends up looking like x plus 3 is our radius, okay? Oops, you can see that better, minus 3. Now for the height, just like what we've done before, the height is basically going to be my upper function minus the lower function. This is like basically calculating the area, okay, between these two curves here. Let's see if I can zoom in a little bit more. Area between these two curves here. So our upper function is our linear 10 minus 2x, so 2 minus x squared minus 6x plus 10. Okay. And if you want to add it all together, you know, don't forget you have to distribute this negative to all these terms. This becomes positive 6x and a minus 10. Okay. And then when I combine it together, I'm going to get minus x squared plus 4x. Okay. And that basically gives me my height, right, which is essentially the difference between these curves here. Okay. So we put them all together into our shell equation. I've got 2 pi times the radius times the height times our thickness dx. And I'm going to integrate again from 0 to 4. 2 pi, the radius we said was x plus 3. Our height is minus squared plus 4x, and our thickness is dx. And that's all we need to do. We don't have to actually work it through or calculate it. Okay. If we were going to calculate it, I could FOIL out this thing and essentially just use the power rule to integrate it, but I'm not going to worry about it because they said not to, just to set up the integral. Okay, so that's the question number 7 from spring 2019 exam. I'm going to pause the recording.